Let's take a look at this duration-based costing problem. G Manufacturing produces two models of camshafts used in production of automobile engines, regular and high performance. G currently uses an ABC system to assign costs to the two products. For the coming year, the company has the following overhead activities, costs, and activity drivers. So if you look here, we see what their expected costs are for the various activities: setups, machining, moving, total overhead costs, the cost per activity, what the driver was, and the activity capacity. And at practical capacity, the expected activity demands for each product are also given. So they make two products, the regular and the high performance, and here's what they expect at practical capacity. And then they also tell us the production cycle time for the regular performance camshaft is 0.5 hours per unit, and the high performance camshaft is 2.5 hours per unit. Alright, so what's our first requirement? Our first requirement is to calculate the consumption ratio for each activity, and then use these consumption ratios to assign the total overhead cost to each camshaft model and calculate the overhead cost per unit of each model. So we're going to figure out what goes in these little boxes here. Okay, so now you see the solution on the right part of the screen. How do we come up with the activity consumption ratio? Well, we take the 8,000, 6,000, and 1,000, setup hours, machining hours, and the moving hours, and we divide it by what? By the activity capacity. There's our 10,000 and 20,000 and 5,000. And we do the same thing for the other model. So you see the 2014 and 4 being divided by the activity capacity as well. So that gives us the ratios we need, the 0.8 and the 0.2, 0.3 and 0.7, right? There's our 0.8, or 0.2. You do the math, that's what you'll get. Your 0.8 and 0.2. Okay? You're going to come up with all of that. So once we have the percentage of the total, we multiply it by the expected cost we expect for each activity. So the 214 winds up here, the 420, which came from machining, gets used, and the 112 gets used. And we indicate which one goes to the regular performance and which one at the high end, and we calculate the total overhead cost. Once we have the total overhead cost, we can divide it by the denominator. And the denominator represents the total units completed. There's our 30,000 and 8,000 that gets used right here. So we're able to come up with the unit overhead cost. Okay, next we're going to take a look at question 2. Question 2 says, calculate the total and per unit overhead assigned to each model using DBC, which is duration-based costing. Assume you only know cycle time, total overhead costs, and units at practical capacity. Okay, so now let's see how we came up with the solution to number 2. So the first step you have to do is calculate the total hours for all the primary activities. Okay, so 0.5 is the production cycle time they gave you for the one product, the regular performance, and the 2.5 is the high performance, the production cycle time. And you're going to multiply that times the 30,000 hours, units completed, or the 8,000 to come up with what the hours would be for each product and in total. Then you calculate the overhead rate. So we take the total 747,112 and divide it by the 35,000 of total hours to come up with a single overhead rate. Okay, then you calculate the overhead rate cost per unit by multiplying that overhead rate, that 21.3461 we just got, times the production cycle time, 0.5 and 2.5. And so we come up with the various rates we need here. So the last step is to calculate the total overhead assigned to each product, which would be the unit cost multiplied by the units at practical capacity. So we take the 1067 that we calculated here times 30,000 and the 5337 that we just calculated times the 8,000. And remember, 30,000 is the units completed and the 8,000 for the regular performance, the 8,000 for the high performance. So that's where those numbers came into. And with that, you can see that DBC and ABC will produce identical cost assignments.